Okay, I'm recording. So what I'm working on today is on an Apple Macbook Pro 2016 um, A1707, which is was a flagship model, still is a flagship model for these years. The problem with this machine is, and already took the liberty to actually take the screen apart, because the problem with this machine is not, is by far not the machine itself as much as the screen assembly. So when Apple actually designed this particular laptop, they actually went from the traditional cables that you see on these older Macs to a ribbon cable. So you can see here, it is an actual ribbon cable that transfer all the electronics, flex cable that is transferring all the data and signals from the screen into the system. So on traditional Macs, that used to be a cable, an actual cables, a bunch of cables that are shrink wrapped together, and sometimes they would break and cause an issue, but in many cases it wouldn't be a problem. It's easily fixed. With these models, with that particular flex cable, there is a problem, and the problem is that the flex cable is a little bit too short, is about 1 millimeter too short, and what happens during time when this you open and close the screen, the cable actually tend to break, and it is a well-known problem with these particular models, and affecting all models from 2015, end of 2015, all the way up to 2018, and there is a name to it. It's called FlexGate. Apple does not acknowledge, well, partially acknowledge that there is a problem with the 2013 and up, sorry, the 13-inch Macbook Airs, and will replace the screen for you. It does not acknowledge that there is a problem with the 15-inch MacBook Pros. And unfortunately, if you have a problem, you have to replace the complete screen assembly, which is this particular piece. You cannot just fix the cable, replace the cable. It is the complete screen assembly. It is a design flaw. I consider it to be a design flaw. Many others. Apple doesn't acknowledge it. This particular client came to me after searching all over the place and trying to make Apple to actually fix that problem for him. This screen assembly, just the screen itself, is around $1,000. So it's a very expensive fix. It's actually the price of the whole computer. I already found that the crack in the cable, already located it. What I'm going to do, I'm gonna do a cable fix. I'm gonna cut and elongate the cable, give it another 2 millimeters, so it will not be stressed out. This is a very delicate piece of work. It's like literally performing heart surgery. It's a very delicate, very easy to mess up. And if I mess it up, I need to replace the screen for the client. So this is a very problematic fix. But I'm going to attempt and do that. Hope for the best. So basically what you're seeing right now is the new cable prep. What I'm going to do right now is I'm going to remove the conformity coating on the cable itself and expose the traces that needs to be soldered. Unfortunately, I couldn't show the process of actually how I cut and measure, but I always start with the new cable, measure, And then if a situation arises that I made a mistake in calculating the length, I can always take a new cable and cut it again. However, if I take the old monitor head and cut it first, and I made a mistake calculating how much I need to cut, we'll be in a situation that I will have very little margin to actually fix the cable, and it's going to be a mess. So this way, I'm always starting with a new head and connecting it to the after making sure that it's the correct length, prepping it and connecting both sides after I already measured on a new head, not making any calculations on the old cable, because a mistake there will render it impossible to fix. I'm going to rush the video here in order to make it a little bit faster. This is a very boring part, takes a long time to clean this cable, and I don't want to make the video too long for that. Okay. Okay, so the head of the old cable is cut, and the new head is already prepared. And now I need to figure out that they are 100% matching. Before I do any, obviously I need to reveal the traces in this cable first, to be able to find a match. So I'm going to do that over here, outside of the Okay, so the cables are, both parts are exposed, and there is almost 100% match. Just need to put them aligned, and that will be the next part. The next part will be to put some soldering material on the traces to make them stronger, and then once we have that, to use a trace line, which is very, very thin wires, and reconnect that joint. That will make the cable a little bit longer. Okay. So at this section I already soldered the wide traces, some of them at least, with just a solder, connected them with just a solder. Some of them can be connected straight with solder. It's enough to maintain the mechanical stability of the connection. The smaller wires cannot be used with the solder only, because the solder is very brittle, so you need the support of a wire. The wide connectors can be supported with just solder, but the thin, small connectors small traces, I always put a trace on a wire in order to maintain the mechanical stability of the connection. The wire is a bit bent, so I cannot use it like that. I'm gonna cut it to size, try to straighten it up. And the trick with this particular fix is not to use too much solder. Just a bare minimum that is needed. And the head is still not straight, I'm gonna cut it off. To burn the insulation of that wire. It's a 0.6 millimeter wire. Trying to place on the trace. That didn't work well, so we'll start again. Create a little bit of more exposure with the sometimes the solder that you have on the wire is enough to actually get the wire connected to the trace. So way too much. Missing a little bit of flux. It's too dry. This work is extremely delicate and needs to be done with a lot of patience. Micro soldering 0.6 millimeter wire. There we go. Did the trick. It's a bit crooked, but it doesn't have to be perfect. Just to touch the trace, so to make the contact. Clean up the area, make sure that it's making good contact. Looks okay. Good to go.
Okay, so I'm just going to accelerate this piece. There's no point elongating this video to more than what it needs to be. It's all repetitive to all the traces, so I'm going to accelerate this part until we get to the next phase. Okay, after all traces are connected from the new head and the old stem going onto the monitor, and making sure that none of these traces are shorting to the other, it's time to actually put the conformity coating on that exposed traces. The reason is that we want to first of all protect the cable from oxidation. The second is to protect any parts of that, the bare metal, the bare wires, to touch any bare metal of the actual laptop and cause a short. And the third reason is to give an extra mechanical stability to the cable. We're going to put a conformity coating on the face on these two wires, and then do the other side as well.
Quite a lot of material. Let me take that. So that ultraviolet light is going to cure it, and then once we cured it, we're going to clean out and do another layer until we get a strong enough bond that is part of the cable, and it's going to become strong enough to withstand long usage. I hope that this is going to be resolving this problem with that client. Let's see what's happening here. I don't think we need the wires anymore. I'll put it back. Let's test that. Yeah, this is not hard enough. We definitely need some more time with the ultraviolet light. Okay, that seems to be strong enough now. Let me do another layer. Sorry about that. Wrong button. So this is hard already, and let's add, first of all, do a quick clean, because this thing is actually releasing a chemical on top, and it does its business, so I'm gonna want to remove that chemical off with a bit of alcohol. Get that clean and nice, and then yeah, run another layer on top of it. Around. Maybe a little bit more ultraviolet. Okay, so placed all the layers, cover almost everything with conformity material. I'm gonna run another quick UV cycle, and then take out the tape and do this part. You see there is a lot of exposed traces over there. I'm gonna do that, and plus it's gonna add to the strength of that cable, and make sure there's no any pinching points that are actually pointing out and can actually cause here we go. Don't like it, that's a bit okay, maybe I'll put some sticky material on that later, so it's not gonna pinch on anything. Okay, let's do another UV cycle. This UV lamp is not very strong, and it takes a bit of time for this material to cure. then we need to do the back of the cable as well, the other side. So that's going to be the next part. Just put another conformity material and UV it on the other side of the cable. Okay, so now that's the other side of the cable, and we're going to use the same conformity material to get that side done before we actually call it a done cable and test it. So I'm going to put some ultraviolet. Okay, so at this stage I have reconnected the screen back for testing with only two provisioning screws. Connected back the cables. I had to stop the cable fixing part because it really took a bit too long applying and reapplying the conformity coating on the cable and sitting, I didn't want to elongate the video by sitting half an hour with UV light in order to cure it. It's very boring, and it's exactly the same. So once the cable was ready, I've actually reconnected it, reattached it to the board. And now I've reattached the screen back into place, and it's time to test. So what I'm going to do, I'm going to start the machine. Actually, these machines are supposed to start when you open them. Yeah, we connected the battery, and okay, so we have backlight, and the backlight is working. And as you can see that I can open the machine, and the backlight is 100% working. And let's let it quickly boot. I don't want to keep it like that, go all the way. And I'm gonna turn the machine off quickly as I can, so client details are not obvious. And yeah, this is the testing part of this section. I'm gonna finish connecting all the moving parts back in place, all the antennas and everything back into position, and with that conclude the video. So this is a problem, a very well-known problem with 2015 and upward Macs. Apple had acknowledged that there is a problem with that particular cable. It's a too short backlight cable, and but does not offer any remedy for any 15-inch Macs. It will offer a remedy for if you have a 13-inch Mac and you need to solve that, you have that problem, Apple will replace the screen for free for you. They will not fix the cable, they will replace the screen. These screens for the 15-inch model cost around anything between $800 to $900 to purchase, and on top of that you have installation. So Apple is not helping to solve that problem. However, we know how to solve that problem. We have the technique, and if you are one of these unfortunate people that have a 15-inch Mac and we tried with Apple, most likely that they will not help you. Although I did heard that in some cases they are willing to take responsibility on particular cases. They are waiting probably for a class action lawsuit before they're actually going to address that. So if you're one of these individuals who's stuck with this problem, you can come and visit us or send us your machine. We will happily fix it for you. If you're in the Toronto GTA area or nearby, even in Canada, you feel free. You can send your device to us. You can actually initiate a repair on the website and send the device to us. We'll be happy to repair it for you. That's it for this video. Please like and subscribe. That will help us get the word out, spread the word out that we actually do this type of fixing. So thank you very much, and bye for now.